write my name?
You should write your name.
No.
Why should I write my name, Harrison?
Don't have to.
That's just weird. Okay. All right. We're going to graph reflections. You might want to use your book to do your homework because a picture of the thing you need to reflect on some of those already. If not, you're going to have to graph them on your own. All right. Reflections on the coordinate plane. All right. A reflection. There's an X in there. It's a C. Called it R-E-F-L-E-X. Like reflection. Totally wrong. All right, a reflection, guys, is a mirror image of the original figure. It's a result of a transformation of a figure over a line called a
Where are my answers at?
all right. We're going to call the line that it gets reflected over the line of reflection. Okay? You're going to reflect it over a certain line. And they'll tell you what line to reflect it over in the problem. That line is called the line of reflection. Okay? In a reflection, each point of the pre-image and its image, so beginning to end, are the same distance. They're the same distance from that line of reflection. Okay? And then the image you make compared to its pre-image, are they the same size and shape?
Yes.
Yes.
What's that word?
Congruent.
Congruent. Very good. The image is congruent to the pre-image. So we're not going to enlarge or shrink down an image yet. That's called a dilation. We're going to do that eventually. Okay. Here's the deal. You're going to reflect things either over this or over the y-axis. So we'll tell you in the problem. So these are on the right. To reflect something over the x-axis, which way does the x-axis run?
This way. Horizontal.
Horizontally. So they're going to say reflected over the x-axis. To reflect the figure over the x-axis, multiply the y-coordinates by -1. All you got to do. xy becomes x comma -y. Multiplied by -1 is just going to change the sign on it. Here's the picture of it, blue to green. The x-axis is not very good to see here, guys. I apologize. It's right there. So you're going to reflect it over the x-axis. The x values actually stay the same. The y values are multiplied by -1. That's what you're going to do. We're going to talk about how to memorize that, some tricks and stuff like that. But if you want to reflect something over the y-axis, which way does the y-axis run?
Vertical.
Vertical. If you want to reflect it over the y-axis, the y values actually stay the same, and you're going to take your x values and multiply them by -1. Once we do an example, guys, you'll see what we mean here. Okay? All right. Everybody put a big old star by this stuff and write the words memorize. You're going to have to memorize that info. It's not, we'll give you some tricks to help you, but it's your responsibility to remember. We're reflected over the x-axis, multiply your y's by -1. Reflected over the y-axis, multiply your x's by -1. Let's try a couple problems to see if you guys can put all this stuff together. Okay, what should we do, guys, when we reflect something over the x-axis? Now, when we reflect something over the x-axis, this is what this problem is talking about. Does the x value change?
No.
No, it doesn't. So, put the word no in here. You guys, it's okay if you don't know it. We won't talk about it for a minute. So, the x value does not change when we reflect something over the x-axis. So, here's Miss Perillo's little trick to try to help you remember this. X-axis, x stays the same. Does the y value change? Yes. How so? Well, what if it's a negative? So what's a word that would describe kind of what you're saying? about this? Multiply by -1, or what's it called when you multiply any number by -1 and get the new number? That's the opposite. Or take the opposite of the y value. That's what I would do. That kind of makes sense in my head. But that's the same thing as multiplying by -1. All right, let's do an example. Watch how this works. Quadrilateral QRST has vertices at QR, S, and T there. Graph the figure and its reflected image over the x-axis. So the problem has to tell you where you're going to reflect it. Over. Okay, everybody circle or underline the x-axis. Okay? We're going to reflect it over the x. So it's going to start up here and it's going to be reflected down here, I think.
Mr. Pantini,
What?
can you pick up a question? I have a question.
Okay, hold on one second. Hi, Miss Brillo. Swell, how are you? Yeah? I think if there's multiple variables, it really doesn't matter, but you can do your best. Ah, you're right. Yeah. You by the H. I think it doesn't really matter when there's multiple variables. It's. I don't think we'll give them. We wouldn't say put it in standard form. You know what I'm saying? Just when there's one variable, you go by descending order, right? Don't you think? Yes, exactly. Okay. Back. All right. So, we're going to reflect it over the x-axis. What I want you guys to do first is graph the original QRST if you've not done so already. Graph Q, R, S, and T. It'll be a four-sided figure. So -1, 1. There's Q. R is at 0, 3. So it's 3 units up on the y-axis. There's R. S is at 3, 2. Over there in quadrant 1. And T is at 4, 0, which is right on the x-axis. There's T. Connect your 4 points to show a quadrilateral, a four-sided figure. Go ahead, Ange.
If you flip it, would it turn like the reflection? Would it turn to on prime, C prime?
Of course, yeah. That's what we call it. You always call your new points the little prime thing. Good question. And I got them labeled down here, Angie, at the bottom. Okay. I think before you actually start graphing it, again, we're going to reflect it over here. Let's get the values of Q prime, R prime, S prime, and T prime. Here's how we do that. The X values stay the same, and the Y values you multiply by -1. So, to get Q prime, who can keep the X value the same, but multiply the Y value by -1? And tell me, what's Q prime? This is so easy. Jack Muir. -1, comma -1. Explain in your words how you did that or what you thought of, so maybe you can help somebody else out.
The original point was -1, comma 1, so then I took the y and I times it by -1, which is -1.
And what'd you do with the X value?
-1.
You kept it the same, right? Guys, all you do is keep the X value the same and take your Y value multiplied by -1. Get R prime, S prime, and T prime. Go. Minetti, what's R prime?
R prime. Oh wait, I was R prime is 0, -3.
Genius. He kept X the same, and he switched the sign on the Y value, or multiplied it by -1. Connor, what's S prime?
3, -2.
You got it. 3, -2. Mr. Lance, what's T prime? Watch this. 4 comma 0. You know what they said last period? 4 comma negative 0. Okay. Is 0, can 0 be negative?
No.
No, it's neutral. It's not positive nor negative. So, if the value is on the x-axis, it's going to stay there. Okay? Now, I got the luxury of different colors. If you guys have different colored pencils or something, you can do it there. Graph the reflection and watch how it looks. -1, -1. 0, -3. 3, -2. 4, 0. What do you guys think? If you do it with a straight edge, it looks really cool. If you do it with a straight edge, it looks really cool.
Looks like a fortune cookie.
It's like the Pac-Man.
It's like a what?
Fortune
Pac-Man?
cookie.
Oh, kind of, I guess. It looks a little bit like Pac-Man, but more rounded. So, for your homework, guys, you have to name the coordinates of the reflected points and graph it. It's not bad. You just have to remember when to multiply by -1 and which one.
Mr. P get the graphs provided.
What's that? In the book, yes. If not, I have graph paper up here if you want to use the Chromebook and do it off the screen. Harrison.
Would they ever give you the reflection and tell you to find the original?
Good question.
Maybe. We just did this page. I think. No, we
Same
didn't.
thing? No.
Did Harrison?
This one we're going to do, we're going to reflect it over the y-axis. Circle in the problem, reflect it over the y-axis. Now, if we're reflecting things over the y-axis, does the y value change?
No.
No. Y-axis, y stays the same. How does the x value change? Or does the x value change?
Yes.
How? Times it by -1. Multiply by -1. Or, what's another word for that? Take the opposite of the x value. The opposite. Right? Looks like we're going to reflect a triangle here. Let's graph the original one first. Okay, practice graphing, guys. Some of you guys are still not thinking enough while you guys are graphing. -2, 2. That's P. Q is at 0, 5. Up on that y-axis. And R is at 3, -1.
Nice try.
And we're going to reflect it over the y-axis, the vertical axis. Wait, part of the triangle is on both sides. How could that happen? Can you flip it? Yeah. It's part of it's going to be on this side, and part of it's going to be. It's like the small part's going to be to the right, and the bigger part of it's going to be to the left. Okay. Let's get the coordinates of P prime, Q prime, and R prime. Times x by -1 and keep y the same. Times x by -1 and keep y the same.
2, 2.
Okay? P prime will be 2, 2.
2, 2.
2, 2.
2, 2.
Okay? Raise your hand if you got Q prime. Miss Catherine, what is it? Yeah, it stays the same. It's 0, 5. It's already on the y-axis, so when we reflect it, it's not going to move at all. So 0, 5. Teddy, what's R prime? -3, -1. Very good. Graph those guys. Again, if you have different colors, use them. 2, 2. 0, 0, 5. Stays right on. Oh, I got to label them. P prime, Q prime, and -3, -1. R prime. Look at that, people. How's yours look? Does it look like a reflection?
Not really.
But hey, you gotta look at it carefully. It does look like a reflection. You know, they reflected it. All right, this next one. You guys already have. You guys see a picture of half a heart?
Yeah.
Half a heart. Okay. Looks like that point's there. I gotta draw it real quick. A is at. Where's point A at, guys?
3, 2.
I'm gonna say it's at 3, 2. And B is at 1, -2.
Yeah.
And it looks like it goes down to here. All right, so And then is yours shaded in?
Yeah. That's pretty good. I thought I did it.
Okay. There's A,
Do this.
B's right there. Okay. You're going to try to reflect that over the y-axis so that you can complete the heart.
Did it.
Smart thing to do first, guys. Everybody label what you think points A and B are, the originals, the pre-image. What's point A?
3, 2.
3, 2. Point B? 1, -2. Got those down. If we're going to reflect it over the y-axis, which value do we multiply by -1? Okay, we're going to do the x times -1, and then the y value stays the same. Jot things down to help yourselves out. So take A and B, multiply x by -1, keep y the same, and you will reflect those points. Gracie McGuire, what's the coordinates of A prime? Perfect. -3, 2. And Shannon Hopkins, what's the coordinates of B prime?
-1, -2.
-1, -2. All right, finish off your heart now, people. -3, 2.
Yeah.
There's A prime. And B prime is at -1, -2. B prime, and then try your best to draw your
I get it's for Valentine's Day.
Valentine's Day.
Oh, it's for tomorrow.
I'm gonna color it in. How many people's heart look pretty good? Let me see your hearts.
It's for Abraham Lincoln's birthday.
That's pretty good, Harrison. Nice, Ange.
Mine's for
Oh, Trace, that looks like a kidney. All right. Last one. We had a very lively discussion on what the Jesus this was. We wrote down that.
explosion.
Yeah, that's what they said. It was an explosion. Then somebody was real creative. They said it was Maggie Simpson's head. Kind of looks like Maggie Simpson's head.
I get it.
Get it? One of the Simpsons? Thought it was maybe a leaf or a sun. All right. All we're going to do, guys, is reflect points A and B over the y-axis this time. No, the x-axis, excuse me. The vertical axis. Label points A and B. X-axis, X stays the same. And then Y gets multiplied by -1. Okay? Can you guys see that your graph does not look good, right?
Ours does not have.
It's hard to see. Look up here, guys. What do you think the point A is?
It's the sun.
-2.
Yeah. The point A, guys, is -2, 2. It's really hard to see on your notes. I apologize for that. Write that down. That point A is -2, 2. And what's the value? What's the coordinates of point B?
2, 2.
2, 2. 2, 2 again. All right. Keep x the same and multiply y by -1 to find A prime and B prime. Okay. Devin, what's the coordinates of A prime?
2, 2.
You multiplied the x's by -1.
2, -2, -2.
Right, -2, -2. Keep that straight. -2, -2. That's why maybe jotting it down, people, might help you. Okay. Billy Coyne, what are the values? What are the coordinates of B prime?
2, -2.
2, -2. Graph those, and it's label them A prime and B prime, and it's kind of tricky to draw that, but you can do it.
I did it.
I did. Oh, yeah.
That's close.
It's really
Not
bad.
bad.
I did
I'm not the best artist.
Yay.
I did get the coordinates of A prime and B prime, and that's the important thing. All right, last thing. Now you've got to think the exact opposite of this. They're going to tell you the how A became A prime, how it reflected. Your job is to decide, was it an x-axis or a y-axis reflection? You guys got to know your rules, okay? if A was negative 6, 7, and A prime became 6, 7, how was that reflected? See if you can figure it out. What do you think, Teddy? That's a y-axis. How'd you know? What'd you think of?
Because when you do a reflection of the y-axis, you multiply the x point by -1.
And that's what happened, right? So, that's, guys, excellent answer. That is a y-axis reflection. Because the x's changed signs. How about the next one? Negative 3, 8 became negative 3, negative 8. What was that reflected over? The x-axis. I bet that's on in your homework, guys. So, again, you know your rules. You're going to be good to go. All right, signing off, guys. Say goodbye.
Bye.
Bye.